Hi, this is Lab 1, Constant Velocity Motion, where we were asked to record a video with the constant velocity, observe the motion of the object, and make a model using a computer, based on Newton's second law and the momentum principle. Constant velocity means zero net force, and we already know how to predict the velocity using Newton's second law and the momentum principle. Velocity final equals velocity initial plus net force divided by mass times the change of time. So constant velocity equals zero net force, because for the motion to be constant, or Vf equals Vi, Fnet must be zero, because the mass and time interval are always positive. Okay, so here's the video that I recorded and analyzed. I used the calibration stick as the diameter of the tape, which is 9.5 centimeters long, and placed the coordinate system on the center of the tape with the positive x-axis pointing to the right. So here's the video. I was surprised when I found out that the center mass of the tape is in the center of the tape. That means that it's not on the object itself, which I found quite odd. After that, I took 2 points from the middle and calculated the velocity as shown here. Negative 0.023 meters minus 0.001 meters divided by 0.053 seconds minus 0 seconds, which is negative 0.3774 meters per second. Of course, that's for the x component. Those are the object's properties that I analyzed. The mass is 112 grams and the diameter is 9.5 centimeters. Of course, those are in the SI units. After that, I inserted the new information into Python, as shown here. The initial conditions, which are the initial position and the initial velocity. The initial position is negative 0.001, and the initial velocity is negative 0.3774 meters per second. And of course, here it's meters, only meters. And the tape's mass is 0.112 kilograms, but the mass here doesn't matter because it's zero net force. And here's the time of the last frame, as you see here. Sorry. Fnet equals 0, and here's Newton's second law. Okay, let's run it. As you see here, it's the same movement as the tape in the right direction. And here's the graph with the both model and experiment. And they are very much alike. That's because in tracker, the difference between most points is 2 centimeters. But as you see here, it's a bit off. That's because in the model there was no force, or zero net force, but in real life there's gravity and friction, which affected the motion of the tape. Okay, so what would happen if I changed the orientation of the axis? Well, if I rotated the axis here by 90 degrees, here's what would happen. The ball would be moving in the y direction, in the positive y direction, not in the x direction. And here's the model to see what I'm talking about. As you see here. So the magnitude of the velocity would be the same, but the direction would change if I oriented the axis. Okay. So What does it mean that pushes and pulls are added together to give zero net force in the case that I observed, where there are gravity and friction? Those two forces are affecting the object, but the surface of the ground is pushing the object upward because the gravity is pulling the object downward. So we only care about the friction here. And for the net force to be zero, there must be another force affecting the object in the opposite direction with the same magnitude of the friction. Conclusion. The video that was captured did not have constant velocity due to other forces acting on it, like friction and gravity. That was Lab 1. Thank you for watching.